We have already seen how Dmitri Mendeleev in the middle of the 19th century organized the known elements by atomic mass, and how he discovered that some of the properties of the elements repeated with some periodicity. He produced a periodic table that looked somewhat like this. This doesn't look like a modern periodic table, but we can still recognize a few things. Look here, for example, where we have group 1. Here we find hydrogen, lithium, sodium, potassium, rubidium, and cesium. What's common for all these is that they all have a single valence electron. This was unknown to Mendeleev when he made the periodic table. The electron wasn't discovered until the end of the 19th century. But because they have the same number of valence electrons, they share some features. And it was these features that Mendeleev noticed. There was also something particularly clever with Mendeleev's table, and it was that he left a few gaps in it. Have a look over here, between aluminum and indium. With the help of the properties of aluminum and indium and the other elements nearby, he predicted that there must be an element here with certain properties. It would have a relative atomic mass of 68, it would have a certain melting point, a certain density, and so on. When the element gallium was discovered by the French chemist Paul-Émile Lecoq de Bois-Boudron a few years later, it turned out that it had almost exactly the properties that Mendeleev had predicted. Thanks to the gaps that Mendeleev left and the predictions he made, one could realize what a powerful tool to understand the properties of the elements that the periodic table was. And this is what you will learn too in this video and the following ones. This is what a modern periodic table looks like. It's made up of perpendicular groups and horizontal periods. What characterizes the elements in the same group is that they have the same number of valence electrons, and these are all the groups in the periodic table. And the valence electrons, you hopefully remember that they are the electrons in the outermost electron shell in the atom. This means that in group 1, all the atoms have one valence electron, and in group 2, they have 2. We'll skip forward somewhat to group 13, where all the elements have 3 valence electrons. Group 14, where they have 4. Group 15, where the elements have 5 valence electrons. Group 16 with 6 valence electrons. Group 17 with 7. And then finally group 18, where all the elements have 8 valence electrons, except helium, where there are only 2. And why it is like that, I'll tell you in my video about the noble gases. These are the so-called transition metals, group 3 to 12. In them, the electron configurations are somewhat more complicated, so I won't go into that in this video. Another thing that we can see in the periodic table is that the groups to the right have less metal characteristics than the groups to the left. In this periodic table, the metalloids are red, and to the left of them we find the metals, and to the right we find the nonmetals. By the way, the yellow elements are those that are gases at room temperature, and the blue ones are liquids. Thus, we can see that the groups to the right are dominated by nonmetals, while the groups further to the left are dominated by metals. It's also like this, that the atoms in the groups to the right are generally smaller than the atoms in the groups to the left. You might think that with more electrons the atom becomes larger, but no. In any period, the atoms actually become smaller as we move to the right. This is because there's a larger number of protons in the nucleus of the atoms to the right, which increases the positive charge of the nucleus, which pulls the electrons tighter around the nucleus. Now, in the periods, the elements in the same period share the same number of electron shells. In this period, the first one, we have only hydrogen and helium. There is only one electron shell, the K shell. In the second period, the atoms have 2 electron shells, and in the third one, 3 shells, and so on. This, of course, means that the size of the atoms increases as we move down in a group, because the number of electron shell increases. That also means that the biggest atom, by volume, is francium, down here to the left. If you have followed along in my previous videos, you also know that the atoms to the left of the period table may oxidize, that is, give off one or several electrons. The further away from the nucleus that the valence electrons are, the less they feel the positive charge of the nucleus and the easier they are released. Because of this, the reactivity increases as we have higher periods here. If we instead turn our eyes to the atoms on the right-hand side of the periodic table, they may instead be reduced. That is, they may take up one or several electrons. The closer the valence electrons are to the nucleus, the more they feel the pull from the positive charge and the easier they may take up an extra electron. Because of this, the reactivity on this side of the periodic table increases with lower periods. I'll explain further why the reactivity varies in my video about the alkali metals and the halogens. The group that we find to the far left of the periodic table, group 1, is called the alkali metal group. Group 2 is the alkaline earth metals. Then we move over to group 17, where we find the halogens. In group 18, we have the noble gases. Group 13 to 16 have gotten their names after the first element in each group. That's why they are called the boron group, the carbon group, the nitrogen group, and the oxygen group. Well, to be honest, the nitrogen group may also be called the pnictogens, and the oxygen group may also be called the chalcogens, but it's rather seldom those names are used. The elements in group 3 to 12 are called transition metals. Among the transition metals, we also find these two groups that often are placed below the rest of the periodic table. They are called the lanthanides, or the rare earth metals, and the actinides. As a matter of fact, I will hardly cover them at all in this chemistry course, although they do have interesting properties too. Now, this is something I want you to learn by heart. I want you to know that the alkali metals are found in group 1 and that they have one valence electron. The alkaline earth metals are in group 2 and they have 2 valence electrons. The boron group is group 13 and the atoms in that group have 3 valence electrons. In the carbon group, which is group number 14, the atoms have 4 valence electrons. And in the nitrogen group, which is group 15, the atoms have 5 valence electrons. In the oxygen group, group 16, the atoms have 6 valence electrons, and the halogens, which are found in group 17, have 7 valence electrons. Finally, we have the noble gases, which have 8 valence electrons, except for helium, which only has 2. All of this is important to remember for the same reasons that Mendeleev discovered. Atoms with the same number of valence electrons have similar properties, and if you can learn and understand this, you'll also understand a lot of chemistry. And this is precisely what we'll talk about in the following videos.